The next collection type that I want to introduce you to is called sets. It's going to look very similar to creating a list and creating a tuple, but once again, there's going to be some differences here. So take a look. Back into my command prompt, I'm going to go ahead and create a new set. I'm going to say my set, and I'm going to make this equal to a collection of data, just like a list, just like a tuple. But right away, there's going to be another difference here. When we created a new list, we used the square brackets. When we created a new tuple, we used the parentheses. Here, when we create a new set, we're going to use the curly brace. So I got my curly brace, and I'm just going to put in some colors once again. And blue. And I'm going to close that curly brace. Hit my enter key. I've now got my new set. Now let's go ahead and print out the type just so we can confirm my set. There it is, as of type class set. All right, now I'm going to print out the attributes and methods and whatnot of this new object that I've created called my set. All right, and there they are. And if we look down below, we can see all of the methods there. We got add, clear, copy, difference. I didn't see that one inside of the list or the tuple. Let's see, intersection, union. So there are some differences here, and I want to talk about some of those differences. But first, let's get into maybe some things that are similar and a couple other things that are different here. So we've already got the list called my set. Now a set it's changeable, meaning that we can add elements to here. We can remove elements, although we want to be careful with actually both of those, and we'll talk about that. But it's not ordered. It's not indexed. Doesn't matter what order the data is in, and indexing has no relevance here. We can't access an element within a set by its index, meaning I can't do this. I'll print my set, and remember the square brackets? If I want to gain access to an element within a list or within a tuple, I'd bring in a square bracket, and I would say I want the one that's in the number 1 position, right? If we're treating this set as a list, it would be red would be 0, green would be 1, and blue would be 2. So ideally, when I hit my enter key here, it would return green back to me. But let's see what happens with the set. Oh, trace. Type error. Set object does not support indexing. I cannot get in there and extract, or not extract, but find a value based on its position, its index. Okay? Just won't happen for us. So dropping data in there, there's no order, and indexing is out the window for us. Okay? Doesn't happen. I can add elements. I can say my set dot add, and I can add an additional element here. Let's bring in purple once again. Okay. And let's go ahead and output my set. My set. All right, there's purple now. Ooh, that's a bit different. When we used the append method inside of a list earlier, we appended it, put it at the end of the list. Here, using the add method with our set, by default, it put it at the beginning of our list. Oh, let's see, what else? We can use the len function. My set. So I want to know how many elements are within this set. We got 4. Purple, green, red, and blue. So there's some similarities in there. Syntax is a little bit different. We're using the parentheses to be able to denote that, hey, this is a set. We could also use the constructor, the double parentheses, and we can create a new set using that. Okay? Very similar to our lists and our tuples. But once again, there's some differences in here. We can remove elements. Let's see, if I say my set dot remove, but this takes a parameter, an argument. It wants to know, well, what do you want to remove from there? let's see, I'm going to remove green. And let's go ahead and print out my set again. All right, green is now gone. Now watch this. My set dot remove. I bring in, let's say, I'm going to remove green again. Right? Our program's running, our users are interfacing with it, and they're playing with this set of data. Well, if I try to remove something that actually doesn't exist ever or anymore, watch what happens. I've got an error. Sorry, if it's not there, using the remove method of a set throws an error. But there's another option for us called discard. If I do my set dot discard, I want to discard green. Well, we know green doesn't exist, right? I just removed it earlier, and when I tried to remove it again, it threw an error. But this time I'll use discard. Nothing happens, right? No alert, which could be a bad thing, but there's no error. Just silently, kind of silently does its thing and maybe fails. It just doesn't happen, right? But at least I didn't get that error. But sometimes errors are a good thing, and we can potentially catch those errors. That's something we'll talk about later on. You get errors in your application, and in this case, a legitimate error because green does not exist inside of this set. Perhaps we want to catch that error and handle it appropriately. Here, discard, it'll remove something, it'll discard it, but it does it quietly, kind of behind the scenes. And if it doesn't exist, like, oh well, let's move on. So this is a set. It's still a collection of data. It's changeable. We can add, we can remove stuff, but it's not ordered, and indexing is out the window. It doesn't matter what order the data is in. So try this out. We've created lists, we've created tuples. Now try creating a set. Get a feel for it. Output the directory of attributes, methods that belong to this one, and maybe do a comparison between this and the lists and the tuples. Okay? The next video, I'm going to take you into some of the specific methods that really make the set object shine and really make it stand out from the other collections inside of Python. So first try this out, and then let's move on.